Ah, this city gives me goosebumps. Every time I look at it, just wow. I used to visit the Imperial City with my pa ever since I was a young lad. Now, I'm a grown man visiting on my own to see the beautiful gardens. We're coming up on them right now. Oh. Hello, sir. Thank you. Wow. The grandiose of His Majesty's villa just astonishes me. I shall. I shall. Ah. Whoa. What's going on? What is this? Why is the world shaking? What was that? Yeah, I did. What's an earthquake? I'll see you guys, I guess. Now it's raining. What is going on in this world? Hello? What? What was this tremor then? Was it called that earthquake like he said? Exposed ground? You mean this? This wasn't here before? Whoa, this place goes deep in. What is it? Time to explore, I guess. What? Guess I can't come back out. Whoa. Hey, I know what this is. This is one of those ancient Roman catacombs. These things used to dot the map all over. Better drop these things, I don't want them. Time to go explore, I guess. Whoa. Is this a tomb? Oh, and here's another one just like it. Whoa. Wait. Are these bones? Is that blood? What is this kind of place? Here's some more. Oh, this place is spooky. What's this? Is this the final burial chamber? You have unleashed an ancient evil that you cannot defeat. Doom? What is this? Rats! Oh my god, what is this? I gotta get out of here. Ah! The man first unleashed 13 rats, but soon they began to breed. And with those 13, they quickly grew into the thousands. The guards tried to stop them, but there were too many. They had grown to a size much too large for them to handle. Even the emperor's men had trouble fighting them off. The second earthquake was even harsher, for the rats had caused it. They had eaten through the supports of the city, and with it the city crumbled. In 1935, Charles Richter, the creator of the Richter scale, used this formula to define what the magnitude of an earthquake was. M equals the log of I divided by S, where M is the magnitude, I is the intensity, and S is the intensity of a standard earthquake. So what this formula means is that the magnitude of an earthquake is the log of the intensity divided by the intensity of the standard earthquake. Charles Richter measured many earthquakes between 1900 and 1950. The lowest he set as 0 on the scale, and the highest he recorded in this time period was 8.9. Each increase by a whole number represents 10 times the intensity as the number before it. For example, 4 is 10 times as intense as 3 on the Richter scale. The Richter scale is used because the difference of intensity between the standard earthquake and 8.9 earthquakes are so large that it would be easier to digest if we just used smaller numbers. For example, the difference between 9 and 0 on the Richter scale is that 9 is about a billion times as intense as 0 on the scale. As you can see here, 10 to the power of 9 is equal to a billion. The reason why Charles Richter set 0 as the magnitude representative of a standard earthquake is because the magnitude of a standard earthquake is literally 0, as shown by his formula. M equals log of I divided by S, where M equals magnitude, I equals the intensity of the earthquake, and S equals the intensity of the standard earthquake. If the intensity of a standard earthquake is also equal to the intensity of the earthquake that we're talking about, then we can just replace the I with another S, as shown here. And we also know that a number divided by itself is equal to 1, as shown here. Log of 1 is equal to 0. Why do we know that it's 0? Well, because unless it's explicitly shown otherwise, we know that there's going to be an invisible 10 here, because it's going to be base 10. We also know that this means that 10 to the power of whatever number is on the other side is equal to 1. 10 to the power of what is equal to 1? 0. And that's how we know. From what we learned, we can now answer this question. Our first earthquake in our story measured a 3.4 on the scale. Our second earthquake, the one that was more devastating and caused havoc within our city, measured 9.2 on the Richter scale. How much more intense was a larger earthquake? Well, let's find out. For this problem, let I, capital I, represent the intensity of the 9.2 earthquake, and let lowercase I represent the intensity of the 3.4 earthquake. We have these two equations. 9.2 equals the log of I1 divided by S. 3.4 equals log of I2 divided by S. Well, what are we looking for? We want to find the ratio of the two intensities, I1 and I2, or how many times stronger the 9.2 earthquake was than the 3.4. What we need to do is isolate this ratio on its own. How? With logs, of course. Now, this part can get a little bit tricky, so I think we should just pause this video and work this problem out on the board. You guys might be thinking, hold up. I got that last part, but how did only 13 rats destroy a city by causing an earthquake? Well, the rats grew exponentially by breeding. How do we find how many rats there were when they caused the second earthquake? Well, the second earthquake occurred approximately 30 days after they were unleashed, and these fertile rats grow at a rate of 25%. So we can set up an equation using this information and the PERT formula. PERT is P, which represents the initial population of our rats, times Euler's number to the power of our growth rate, R, times time, T. What is E? E is Euler's number, which is equal to 2.718281828459045. Euler's number is used whenever there is continuous growth. For example, when we measure population growth or radioactive decay. Alright, time to set up the equation. We know that our initial population, or P, was 13 rats. We know that our growth rate, or R, is 25%, which we write as 0.25. And we know that our time, T, was 30 days. So now we set up the equation as 13e to the power of 0.25 times 30. First, we start with the exponents. So, a quarter of 30 is equal to 7.5, right? And e to the power of 7.5 is about 1,808.0424 yada yada yada. And we multiply this number by 13 right here to get about 23,504 or 23,500. And that's how we find how many rats there were after 30 days of breeding. We have now reached the conclusion of our story, and every good story has a conclusion meant to wrap up the plot so that it feels complete. Except for those stories that don't have an ending and just abruptly stop before you get to find out what happens. Those are the worst, and show just how lazy the writers of the story are. Anywho, our ending is an exciting one. See, what had happened was,